All right, I started the recording. Typically I would use OBS or something to record because that's just good at what it does. But I use Zoom because if you're sick, as I've mentioned, please don't come to class. Instead, feel free to join via Zoom. Right? Again, if you're sick, even during an exam day, don't come and take your exams. Shoot me an email so that you can, so that I can rearrange for you to come in and take that alternate time. I already sent out an email with about going over the syllabus. And you can find that if you join the class later and can't find that, you can find it here in the announcements. So I'm not going to go over, spend the time going over the syllabus. I'm just going to mention the basics in case you missed it, which is that firstly, this class is flipped, meaning that you are expected to watch the videos before coming in class. The easiest way to find the videos, and I'll move modules up to the top. In fact, I can do that very quickly right now. You want to click on modules and you'll be able to see what module we're working on with the videos. The videos I try to keep it below 2 hours worth of watching a week. Okay. So below 2 hours. And then in class, that's basically, it's going to be similar to doing to being in the lab session. In fact, there's going to be very little difference between your lab session and this session. The only difference is who is there. And we might do some more, and we tend to do a couple of in-class activities in here. Come on in. No worries. So this week, of course, is because of course this is the first week and you wouldn't have known to watch videos. Conveniently, this is review for object-oriented programming. So if it's been a while, be sure to watch these videos on object-oriented programming. For next week, please watch the videos on array lists. I know that Professor Fiore, if you've taken 1068, will have gone over the basics of array lists, right? How to kind of use them. But here I'm going to be talking about how to use them with generics, how to use them and going into detail about the operations, as well as how to build our own array list from scratch to see how it works. Because in order to understand some of the problems that I'll be testing you on in the second homework, you got to understand how it works internally. So I try to do most of our assignments and keep them fun, and I'll be going into the Fox and Rabbit in a bit to make sure that you're all on the same page there. Array lists, unfortunately, and big O notation are somewhat make work assignments. But from linked lists from week 4 on, they're going to be fairly interesting and fun assignments every week. Relatively speaking, I know a lot of you would rather be playing video games or reading a book rather than working, but I try to make them fun relative to what I could be giving you. Also, in terms of extra credit, the extra credit assignment is up, which is, you can find that, again, also under modules, but also over here under, let's see, the extra credit, why not take the time to teach yourself regular expressions, regex. Since if you've taken 1051 with me, you will have learned regular expressions, so this is kind of a freebie. If not, then take the time. If you don't have too much to do this weekend, or in terms of homework to do, take the time to learn regular expressions. It takes about 2 hours to learn. It is possibly the most productive 2 hours you will have independently learning this stuff. That said, this extra credit is due at the end of the semester. So as long as you get it done by the end of the semester, there you go. There's 15 extra points of assignment points to add on to you. So that's fairly good. They'll be useful in later assignments where using regular expressions isn't necessarily mandatory, but it will help with being able to figure out why some weirdness is going on. So hopefully you went to lab yesterday, and there was and Jovan and Abdullah, they've both been TAs for me before. They're both really good. But if you have any issues, right, just let me know so we can address those. But hopefully they went over the Fox and Rabbit lab. And again, I also sent out a video going over the idea there. But does anybody have any questions about the Fox and Rabbit in general before I start diving into like asking you where you got to? No, okay, so again, I've went ahead and downloaded the Fox and Rabbit here because I reformatted my computer last semester, and so it's always nice. I tried to get Linux working on this, but it turns out Zoom just doesn't like this particular graphics card setup. Or the latest version of Zoom. So I had to go back to Windows, unfortunately, for my laptop. I'm really partial to Linux. But honestly, they all operating systems have their own quirks and their own issues. So, you know. Okay, come on. It's like, here's Windows, just deciding to clam up and not make it and not help. So let's just go ahead and do copy and instead paste. Okay, there we go. So, and that's generally how you should import stuff into IDEs, just by copying and pasting them, right? So with so hopefully, again, to review, you've got the rabbit, your goal is to make the rabbit survive 100 turns, and then your grade is based off of how often you can, so on the square root curve of its survival rate. So there is not really a way to get 100 on this unless you cheat. In the sense that the only winning move is not the play kind of cheating. So if you figure out some ways to get it to work for 100%, I will be very amused. So, and I do know those ways. So let's see, we've got this rabbit, and the first kind of instinct that you want to do is like look at the Fox code and see how it works, right? Now, as I mentioned, and hopefully Jovan mentioned, the Fox code is great for seeing all the different functions you can use, as well as all of the different strategies that that the Fox uses. However, you don't want to just simply copy the Fox code and just, you know, kind of do the opposite of what the Fox is doing. The Fox is the predator. He's got to move around and he's got to just do stuff to find the rabbit. The rabbit can just stay hidden, right? There's two general strategies for survival for the rabbit. The first is staying out of line of sight, exploiting the fact that this is a grid-based system and this Fox can only see in straight lines. So you can exploit that fact and the fact that these turns are asynchronous, meaning that I'm getting some blank faces here. So let's go ahead and draw that. Let's go ahead and actually, should I do paint or whiteboard? I don't know. Do I even have whiteboard installed? Hey, whiteboard, that works even better than this. Okay. Okay, let's do this. New whiteboard. There we go. Okay, so we've got ourselves a pretty pen, and now we've got our Fox over here, right? And he can see in straight lines on a grid, which means he sees in the compass directions, north, south, east, west, as well as all of those diagonals. Okay, but what that means is that any spaces over here or over here, let's go ahead and put that in a different color. Any spaces over here is a blind spot. Any space over here is a blind spot. Make sense? These are blind spots. He can't see you if you're in that area. So if we've got so let's say the Fox moves, okay? So the way it always works is that the Fox looks first. You have to look before you move. You can't, once you decide to move, your turn ends. So you can't look after you move. You have to wait until your next turn. So if the Fox moves and he moves into the line of sight of the rabbit, he hasn't seen the rabbit yet. But now it's the rabbit's turn. The rabbit gets the chance to see him, and now the rabbit can react appropriately. This strategy takes about 10, 15 lines and can get upwards of, I think, a 92% survival rate, depending on how you do it, which is just simply, if the rabbit can see the Fox, move out of the line of sight of the Fox, otherwise stay put. Now, what direction should this rabbit move? Should he move? Well, so this rabbit over, let's go ahead and ignore this one. So this rabbit over here, he could move, well, moving back and away doesn't really help the situation because now the Fox sees him and now we're on in our chase scenario. Likewise, moving forward's like even a worse situation because you're just kind of jumping into the jaws of death right there. So that leaves us with options basically that resolve to like sidestepping, right? And so kind of makes sense that moving back and away is kind of one of your best strategies because you've got the biggest chance for survival there, right? If you move back and away, you're putting distance between the fox and you're moving yourself out of line of sight. Cool. But what if there is like an obstacle in the way and you can't move in either direction? This is where the function can move helps you, right? So we can see that in the Fox code. It's in the Fox code where the fox tries to move in a current direction, if it can move in that direction, it does so. Otherwise, it tries moving in a model.turn. So these are the two functions that in order to get your A, you got to understand, which is the can move and how to use it. That's fairly straightforward. That's just Boolean. And the model.turn. And model.turn takes in two variables. It takes in the direction you want, the direction you're interested in, or the direction of note, like the direction to the fox, and some kind of number, some kind of modifier. And what that modifier is it says, okay, given the direction, the specified direction, I want to make some number of 45-degree turns. So if you pass in so if this is the current direction and you pass in 4, this is what's gonna, the return direction is gonna be 1, 2, 3, 4. It's gonna be this way, directly away. Likewise, the direction, if you say our direction's I, if I is this direction and you pass in 3, I in 3, you're gonna get 1, 2, 3, back and to the right. Now, so that's the first thing. The second thing that I should warn you about is that you might think that going left and right doesn't really make a difference at all. It does make a difference. If you decide to go right first over left first, it does have a huge difference. So let's go ahead and see on the let's go ahead and just show you where we can go with the rabbit from here. Okay, so I'm going to go ahead and run the grader. I'm not going to bother running the rabbit since you can do so yourself and you can see what the rabbit does. The rabbit is running the simulation itself is good for seeing the behavior, but if you want to see how successful it is, right, this makes sense. Sheer random luck means that maybe I get away 1% of the time. That's not good. Let's go ahead and first return model dot, it's a number. I can't remember what numbers correspond to northwest, east, south, whatever. All that's very annoying. So instead, I'm just going to use model dot and stay. Right. By the way, you shouldn't have to. If you're trying to do the code as okay, if the fox is to the north, then I need to move this way. If the fox is to the east, I need to move this way. If you do it that way, it's just going to be very annoying. You're going to have much longer code than you're going to need. You can abstract it instead. If the fox is in direction I want to move in a relative direction. So model.stay, right? That's not going to do much. But then we can kind of do our loop that we see from the fox, which is as follows. Which is looking around from the minimum direction to the max direction, and then looking and seeing if I see the fox. So for in I is equal to model.min direction, I is less than or equal to model.max direction. Okay, two things that I need to make note there, and I++. Okay, first off, one of the most common mistakes I see for if you're like you're pretty sure it should work, but you're not getting a good grade, make sure that it is not a less than. You might have less than, okay, and not less than and equal to. And you may note that when I put in equal to, it suddenly turns into an actual bona fide less than or equal to sign. What this is doing is, but it actually is just 2 characters. It's actually 2 characters long because it is a less than character and a equal to character. But what it's doing is that the font is exploiting something called ligatures built into some programming language, some programming fonts, which make it nice and easy to read. So if I copy this somewhere else, it's going to give me a less than sign and equal than sign. Okay. So if you see this, just note that it's my font making everything look pretty. Okay. Some people love it, like me. Some people hate it. If you hate it, that's perfectly fine. Don't use it. Just be aware of that. It also does this for my comparisons, right? It makes them big, fat equal. Again, it's all about preference. I like having my ligatures there. So anyway, so for I is equal to model.min direction. Here it is. Go up through all the directions, max direction. If model dot, let's see. Oh, if I look in direction I, and that is equal to model.fox, if that's equal to so if I look in a direction and I see the fox, I've seen the fox, but the fox has moved into my line of sight. But since I'm staying still, that means he hasn't seen me yet. So in that case, I can react. So what I could do is I could do something like this. I could immediately return return model.turn. I is the direction to the fox, and I'll move 4. That's going to be directly away. Okay, right? So I see the fox. I'm going to move. If I see the fox, I'm going to move directly away from it. Doesn't really work for me that much, right? It's about as effective as staying still. On the other hand, if I see the fox and I move back into the right, suddenly my escape goes up quite a bit. Now you want to experiment right versus left, seeing which is better. This is because the fox has a bias in which directions he's going to turn and bounce off the walls when he's pacing, because that's what the fox code does. If he can't see the rabbit, he's just kind of pacing in lines back and forth and bouncing off in random directions when he can't move forward anymore. Okay. So instead of this, of course, what you're going to want to do is a bunch of if statements. All right. I'm going to leave this up for you for right now, because this is quite a bit for you to get started with. Now that's strategy number 1. This is what I consider the most successful strategy. Strategy number 2 is what's referred to in MMORPGs as kiting, as in like flying a kite, kiting. This is a strategy in which typically one player basically aggroes an enemy, meaning it gets the big enemy's attention and runs the heck away while everybody else peppers him with damage over time spells, or other non-attract things that don't attract the monster, and basically it just becomes a war of attrition, as opposed to just trying to, slam the enemy with all their attacks. So in this case, the application here is just you move the same speed as the fox, right? So there's no reason he shouldn't be able to catch you. Also, there are some situations where you might be able to get him into an infinite loop if he sees you, right? If he sees you, you should be able to move in a direction and kind of manipulate him. So there is that. That strategy is a lot harder, I think, to do. It can be very satisfying if you do it, but so I urge you to try this strategy. If you try the second strategy, try it for a bit. If it doesn't work, move on to this strategy, because it's pretty good. Now I have this set to be due at Tuesday evening, but I am very responsive to students, telling me that they need more time and stuff. Okay. So if I get a bunch of emails saying that we need more time, I'll just extend the due date. It's that simple, right? So because I do want to try to introduce array lists on Monday so that we can do Monday, Tuesday, so you can get the introduction before you go to lab. So the TAs don't necessarily have to introduce the labs themselves. So I would like to try to, but again, if you're still working on this on Monday, that's perfectly fine. But I'll probably start by introducing the array lists. If you're feeling like you're going to be falling behind, don't worry about it. That's fine. What my plan is typically go over for about 10-15 minutes. It's 20 today because it's the first class that we're actually meeting together. And then I spend the rest of the time going around and seeing what you're doing and helping you in your particular scenarios. Okay. Again, this is the entire point of this is so that I'm here to help you, you know, in situations where I'm most available to. I know it can be a bit annoying to learn by YouTube videos. I try to make them not so bad, but in exchange, you know, you've got access to me in a one-to-one way that, or on a two-on-one way that you normally would not have access to in a class, right? So, and I find this work, and I've been doing this class since about, or some variation of this class since about 2012, I want to say. This is the way that 2016, since 2016 at Temple. This is, I found, is the best way to teach this class. Okay. All right. So with that, I will go around and help students. First, is there anybody on Zoom who needs